welcome to all the attendees to this webinar today. Let's have a quick look to the agenda. We would like to start with the current situation analysis in histology that lead Milestone to develop the new processor called MAGNUS, and then we will introduce the MAGNUS processor, moving to a live demo session from Milestone Laboratories. As explained by Michela, we will then accommodate all the questions, answer to your questions at the end of this session. Here is a quick summary of the situation in the histology laboratories. It is quite common worldwide to assist to a consolidation process. So basically a unification of smaller and medium labs into larger ones to control basically the costs and to maximize the processes. Any manager, an histology manager in these days is quite familiar with this situation, where compared to the past, a laboratory needs to manage more specimen volume with the same or basically less budget and personnel. At the same time, we assist to an increasing complexity of the tests with the advancing of molecular pathology. It is obvious that in this scenario, the conventional approach would not be feasible anymore. For conventional approach, we mean the utilization of conventional processing method where tissues get accumulated throughout the day and processed during the night with very little rapid processing during the day. So the laboratories will need to rethink the routine and try to improve the turnaround time and workflow. Therefore, the industry should provide new tools and applications to assist this process. In terms of tissue processing, this means that the processor should reduce the specimen turnaround time, but at the same time be flexible to optimize any kind of tissues and workflow. Obviously, reduce the operating cost, as mentioned before, very critical aspect. Be reliable and offer uptime, good uptime, even for daily operation maintenance. Be safe for the specimen and the operator. It includes the auto-embedding in the workflow. So these were basically the base discussion background when Milestone started to develop the new process called MAGNUS. Here it is, the processor that we are going to describe in a moment. We hope that this unit will become a game changer in tissue processing and that will assist laboratories that will manage a new volume and new challenges. More in details, let's discover the MAGNUS processor. The key feature of this machine is on the top part where are located on the left-hand side the reagent retorts, where the fixative and the processing reagent get loading, and the secondary retort on the right-hand side where the wax paraffin remain melted at 65 degrees Celsius. Our protocol are based on ethanol isopropanol, so we provide a xylene-free operation. As you can see in the picture, there is a robotic arm. Actually, it is a dual robotic arm with independent cover, and that's the key of this instrument. The first batch gets loaded into the main reagent cavity, and at the end of the last reagent is automatically moved into the wax retort to complete the wax infiltration of the product. At this stage, the operator can start a second run, basically with achieving a continuous throughput and minimizing the time between the batch loading. A second element important to maintain a continuous operation and quick daily maintenance is the sliding drawer at the bottom part of the system. You will see also in the live demo how the reagent get replaced one important aspect is that we allows the utilization of commercial containers, so the replacement of the reagent is very quick. Without moving the wax that, as explained, remain in a dedicated retort, is not necessary to run at the end of the processing cycle a cleaning, a purge cycle of the main retort. So the wax stays in its own retort. So the reagent load in the drawer is all dedicated for processing, and in this way we avoid wax to go around and cause clogs in the plumbing, hydraulic circuit and valves. So how we obtain throughput, enhanced throughput and flexibility. As explained before, the conventional approach where we accumulate tissues from the night before should be avoided. So basically we need to avoid peaks in processing results and try to optimize the volume throughout the days. In this way, we are able, through a rapid processing, to provide a slide to the pathologist on the same day. Obviously, we need to implement rapid processing protocols. Here is a schematics table of our protocols. So we basically can go from an hour of processing for the small biopsies such as GI and endoscopic. The hour process, in this case, include the fixation and the timing for pump in and out the reagent from the cavity. So this is the full processing time from fixation for fresh tissues to the wax infiltration. And for each millimeter, basically, of thickness, we need to increase another more or less hour, 15 minutes. Let's take, for example, the 3 millimeter. If we have a batch of skin excisions of 3 millimeter of thickness, we need a total of 3 hours to get the tissues protocol completed. So the dual, as explained before, the dual robotic arm allowed a continuous operation. So in this case of the 3-hour protocol, when the first batch is ready to complete the last reagent and get moving to the wax, I'm ready to start a second batch, and basically I can run single batch, I can load a single batch every 2 hours. So that's the way to improve the throughput and the turnaround time of the entire workflow of the process. The total capacity of the MAGNUS with the standard rack provided for rapid processing is up to 210. We have also different kind of racks to accommodate larger tissues such as super mega cassette, and you will see in a moment in the live demo. Obviously, if laboratories want to achieve lean workflow, it is not recommended to run large amount of cassettes for each batch. The literature indicated that the right amount of number of cassettes per batch is below 50. That's because an operator is the amount of tissues that an operator can prepare in an hour, and therefore move the batch into the processor. So let's take this example where we confront the MAGNUS versus a conventional kind of processor. And let's take 45 as cassettes per run, supposing we have a small GI biopsies that can be processed in an hour. Here will be the schedule of MAGNUS and a conventional. So a conventional, supposedly a conventional could run also a protocol in an hour. Between a cycle and a second one, I need to clean the main retort. So in a period of time of a morning, I can run only few cycles. On the contrary, on the MAGNUS, the moment that the first batch, 5 cassettes, in this case, complete the last reagents and get moved to the second cavity, the operator can start to load a second batch, and so on for the continuation of the morning. So as you can see, more than double of the productivity is achieved from MAGNUS by the MAGNUS compared to conventional processor. As explained, the MAGNUS benefit in this case are definitely continuous access to the operation, because there is no cleaning cycles between the first run and the following run. And very important feature, there is no downtime requirement for the reagent replacement. So the operator can, in case of a reagent that gets exhausted, can replace it while the unit is running. Those are the conventional limitations, where at least 35 minutes of cleaning cycles is required between the runs, and in case a reagent runs out, there is a downtime because processors cannot be used while the reagent gets, at least the majority of processors cannot be used while it is. Cost saving, we mentioned that as an important factor today in the management of laboratories. As explained, the xylene-free operation, so the ethanol isopropanol protocol done in the MAGNUS, allows, of course, a green operation, so no exposure for operators to this toxic reagent. That also results in a saving in the reagent disposal. The non-utilization of clearing solvents also results in saving cost. The utilization of xylene substitute prolong, extend significantly the life of paraffin wax, because the paraffin wax is not chemically damaged by the xylene substitute. So also this is in results, giving results a good cost saving. I add also the minimum time required for operator to replace the reagents, and therefore operator, compared to conventional processor, spend less time in maintaining function of the system. Quality, obviously, it's not a compromise if you want to choose rapid processing, at least with our processor. Here you can see some example of tissues, and as you can see, there is no compromise also in the process of fatty tissues, such as colon or breast tissues. Of course, also the immunohistochemistry do not get compromised in our rapid protocols, as long as you do the formalin fixation, and molecular results as well do not get compromised in rapid protocols. Now have a look to the features built in the MAGNUS to improve the safety for specimen. We already talked about the sliding drawer, but I want to mention about this particular feature, a built-in reagent barcode scanning system that you will see in a moment in the live demo to control and double check the right container of reagent that get loaded on the processor and the correct position. So this way we avoid errors, operator errors that could happen in a busy laboratories operation. Another important hardware that we built in the MAGNUS is the differentiation of the hydraulic circuit to move in and out the retort to subgroup of reagents. One dedicated circuit is for the water-based reagents, such as formalin and 70% alcohol for flushing. And the other important subgroup are the alcohol-based for the process, like ethanol, isopropanol, or our proprietary MAI1 and MAI2. It is important to keep separate these two subgroups because, as you know, when we have too much accumulation of water into the, in particular, the 100% absolute alcohol for process, is when we start to see the most detrimental effect on tissues and having morphological problems. As an option, we also make available and we search on the market a high-sensitive ultrasonic reagent sensor to double-check the purity of the reagents and to discriminate the wrong reagent before the process. The ultrasonic sensor is able to catch 1% of water contamination in reagents. So it's a very low threshold. The reagent can get a check before and or after the processing step. So we are able to discriminate and not use a contaminated reagent, but also a wrong type of reagent. So this kind of sensor is able to tell the operator that the ethanol that supposedly should go in the cavity is not the right one. So very important feature to prevent, again, accidental problems during the process. In these days, any kind of instrument in the laboratories should not be anymore as a standalone with no communication, but should be connected to the network and in particular to the laboratory informatics system. Thanks to the Milestone developed software, we are able to keep in communication the MAGNUS to the laboratory informatics system and to provide the histology supervisor or histology manager important information on the processing data. The software also is able to send a notification in case of malfunction or in case of important notification from the system to the operator through emails, text message, or phone calls. The auto-embedding, as mentioned, is an important step that for laboratories that are looking to improve the turnaround time and maximize the workflow to be taken in consideration. Milestone developed years ago the synergy method for our existing line of processor, and of course the MAGNUS can accommodate the synergy method as well and maximize this auto-embedding method. We have a dedicated, as you can see here, a dedicated rack, and the auto-embedding is achieved through dedicated molds where the specimen is placed. In this case, the cassette with the identification goes on top, and in between there is this pad to maintain the position of the biopsy. How does it work at the synergy? The rack has a two leverage positions. So during the reagent process, the assembly inserted into the rack of mold and cassettes are set in an angle so the reagent can flow in and out without retention. At the end, when the rack is moving to the wax, the assembly mold and cassettes assume an horizontal position to complete the wax impregnation and to remove the wax at the end of the infiltration phase. So the result is a complete process and embedded block of tissue with the same protocol speed that we have seen before. I now leave the stage to our application team, Beatrice and Lisa from our laboratory.
This is Beatrice Gamba speaking. Good morning or afternoon, everybody. Together with my colleague Lisa from the lab, today is our pleasure to talk about technology, and in particular to show you in action our MAGNUS unit, the new high-throughput lean tissue processor. We start from the upper part of the unit where the working area is located. There's a cover that allows to create a safe work environment where the retorts are present. Behind the retorts, the area is also vented. During the processing and the rack movements, the cover is normally closed, as it is now. On the other hand, when the user needs to load the rack, the cover can be opened. A carbon fume filter is also built in inside this enclosed cabinet. The first feature of MAGNUS we will talk about is the productivity, that is for sure enhanced from the presence of an innovative double robotic arm. It can manage 2 racks simultaneously in an automatic way. In fact, in MAGNUS, we have 2 independent cavities that are not connected. As Lisa showing, a normal protocol starts from the left main retort. In this cavity, all the reagents contained in the tanks inside the drawer are loaded to perform the fixation, dehydration, and clearing phases. The retort on the right is dedicated only to paraffin. The paraffin never moves from the right cavity. It can only be discharged when needed is changed the change. After the phases in the main cavity are completed, the first arm brings the rack into the paraffin cavity. The second arm is now available to start with the second program in the main retort. Through the software, we know when we can start the second run according to the wax cavity availability. As you might have noticed, while the unit is working, a color-coded light system helps you to visually understand the actual status of the unit so that it can be easily understood from a distance. While the program is running, the light color is blue. And when the program is completed, the light turns green, together with the sound. The third light color that can be seen is yellow. This light color means that the unit requires the attention by the user when a reagent needs to be changed. When there's an error in the unit, the light in the working area turns to red, and you also hear a sound. Since the paraffin is never moving from the right retort, there's no need to have a cleaning cycle of the main retort from paraffin. It is always the rack that is moved from left cavity to the right cavity through the robotic arm. This means that there is no waste of time or downtime to clean the cavity, which is always available when free to load a new batch. Through the double arm and the absence of downtime, you can reach a very productive turnaround time. There is also a third cavity in the front of the working area. This is the paraffin reservoir. This unique feature has 2 main functions. The first one is the wax replacement. This means that in less than 3 minutes, the wax used in the processing is completely changed when needed and ready to be used without any stop for paraffin melting. The second function is to maintain the right level of paraffin in its cavity to avoid situations of low paraffin levels during the process. Let's have now a closer look to the cassette rack available in MAGNUS, depending on throughput and cassettes. In MAGNUS, the standard rack is the 210 cassette rack, made up of 3 layers of 70 cassettes each. For higher throughput, operator can use the random basket 300 cassette rack. The use of this rack increases the capacity of Magnus to a total of 600 cassettes simultaneously. According to the type of cassettes in the lab, other different racks are available. The super mega cassette rack, where the maximum thickness of specimen is 1 centimeter or even more. Operators can also use the super mega slim cassette rack, where large specimens can be processed, but with a thickness up to 5 millimeters. An innovative system available in MAGNUS is the auto-embedding synergy. The synergy system allows the total automation of the embedding process, eliminating the need to reopen the cassettes and reorient the tissue during the embedding. This is due to the fact that the embedding is performed directly in the unit. The synergy system is composed by a special rack and dedicated molds and pads for processing and embedding in one step. The molds are available in 2 sizes for little biopsies and big specimens. The special pad allows the specimen orientation and to maintain the sample in position during the process. This pad was selected for an easy cutting at the microtome. This rack allows the mold cassettes to be placed in 2 positions. In the main retort, the mold cassettes will be placed in an angled position to allow a good reagent circulation. In the wax retort, the mold cassettes will be placed in a horizontal position, so that when the rack is taken out from the paraffin, the mold acts like a spoon, maintaining the wax inside the mold for an automatic embedding. After the removal of the rack from the unit, the operator only needs to extract the complex from the rack and put it on a cold plate. After 10 minutes, the specimens are ready for the cut after opening of the complex. In this way, we have eliminated the phase of reopening of the cassettes, and therefore, we have reduced the possibility of error or loss of specimens. We will show now the touch screen terminal, through which the MAGNUS is controlled by the user. Our intuitive icon-driven user interface allows easy operation at all times. The start of the program can be done from processing icon, but users usually prefer to start from their own favorite programs. We can now move to the sliding drawer with the reagents. For ease of use, MAGNUS can operate with standard 5-liter tanks or with 1-gallon commercial tanks. The use of commercial tanks gives to the user the possibility to connect his own tanks and change the exhausted reagent in less than 3 minutes. The fast reagent exchange allows to reach an improved turnaround time. MAGNUS is an open system, but dedicated reagents such as MILE1 and MILE2, our green reagents, can also be used to improve the quality of fatty tissues with rapid processing. In the sliding drawer, there are 9 positions for tanks, which are all dedicated to tissue processing for longer unattended operations. Another unique feature is the possibility to change the reagents during the processing to reach a very short turnaround time without the need to wait until the program ends. We will show now a reagent exchange with all the interesting safety features that we have added to avoid incorrect exchange of reagents. We start by detaching and taking away the used exhaust tank. To eliminate reagent replacement errors, optional barcode scanning capabilities of the new tank are present. 3 different levels of safety can be activated during the reagent exchange. The first one is the lot code of the new tank. If enabled, it's mandatory to enter the reagent slot during the replacement. This data is important for documentation and internal lab information. The second one is the reagent code. This code normally identifies the reagent type, so it is different, for example, between ethanol and isopropanol. The last one is the hose code. This third safety level refers to the tank position in the drawer. We have already completed a tank change. The reagent exchange is very fast and easy, even if we activated all the controls to avoid any errors. And with this, we conclude our explanation. We really do hope that this practical part has been clear for everybody. Now I give back the floor to Marco for the conclusions. Thank you.
Thank you, Beatrice, and thank you, Lisa. Let's have a summary of the MAGNUS and in particular of Milestone approach to the rapid turnaround time. So as seen, our approach is to have a processor in the lab that is able to reduce the specimen turnaround time with rapid protocol, but at the same time with the flexibility to optimize any kind of workflow. This is because you know better than us that in histology workflow, it is not possible to predict the type of tissue that will enter in the door each morning. Quality, obviously, it's a prerequisite to move into a faster pace and faster turnaround time. At the same time, summary of operating cost reductions is very important in these days. The safety for the specimen and for the operator in these days is also very important, and therefore we privilege and push the xylene-free process. Auto-embedding is a reality today, and it is possible to achieve it with the same protocol times for the completions of the full process. Reliability and uptime is also very important to avoid problems for tissues and, of course, to not incur in extra cost or problems. Then automation for continuous throughput. In this case, the MAGNUS offer the dual run or continuous operations to achieve a better pace. In summary, it's possible with MAGNUS to run several protocols during a shift during the day for small biopsies and still maintain the capability of full operation of a processor for the large and fatty tissues, maybe during the night when you have more time to accommodate the longest protocol for the fatty tissues. The full capacity with the random basket is up to 600 cassettes when we consider the dual run in simultaneous, and with the continuous operation, we can guarantee no downtime even for daily maintenance, such as the reagent replacement or with the extra wax reservoir for the wax replacement.